So on the rear of this unit here, now you can see the adductors. There's a pair of them. On this particular one, you've got a valve. So there's a butterfly valve in that one. Wonder why I've got a butterfly valve in there. Well, let's go back to where we put the air in. Now you can see there's a 2-inch mince-up coupling. So it'll require a 2-inch bull hose with a double bolt clasp, done up correctly, the whip check. Ensure that the hose is all the way home to the back of the ferrule on the stem of the fitting. Ensure the bolts are nice and tight. Ensure that the gasket here is in good repair. And ensure that this gasket is in good repair as well. So it needs to be flat, not undermined or damaged. Sometimes these are a little bit awkward to put on. So I suggest you get some assistance to help you hold the 2-inch ball hose up in the air. The other thing I suggest too is just smear a little bit of graphite dust around there, because these can become quite tight because there's significant protrusion of the gasket from the fitting here. So to twist that round, if you put a little bit of graphite dust on there, it'll slip and go into the lock dogs on each side. Bull hose, mandatory 2 pins, not just 1, but 2 pins. We need 2 pins because if this twists, 1 pin is not substantial to hold that massive mince-up coupling. So the whip check, remember, has to be on there, and it has to be fitted on this back side of the mince-up coupling, pulled taut and on the hold. The back of the hose so that it's taut, no slack. So that's your feed line, that's your primary air in line. So once the air's connected, I have 2 more valves. So each valve feeds air to each adductor side. So these are the vacuums. These are the part that goes and sucks everything through that particular pressure vessel, or receiver is its adequate name. So what happens here is that prior to turning the main air on, just check that these valves work correctly. Sometimes they're a little bit tight, so just check that they work, like so. All good. So now I can send the air through to this particular unit. So as I mentioned, each of these requires 350 CFM of air. So collectively 700 CFM of air. So let's say, for example, I didn't need all that suction just to finish off a job. I don't need one of these adductors. So basically what I can do is, I can turn one of these off if I don't need the pair of them. Brings me back to 350 CFM of air just for one side, but it's only for smaller sections. And remember, if you turn one of these valves off, it has a detrimental effect in relation to what the gauging now is telling me in regard to the vacuum. This is designed for 700 CFM of air, and ultimately we'll use 700 CFM of air. But if I don't need one of these, I'll turn this valve off and that valve off up there. So that stops this section from actuating. So the suction hose that's drawn through from this receiver comes into the middle of this. So by turning this valve off and that valve off, it isolates that particular unit. If you leave that valve on, it still draws backwards then through there, and this one's trying to pull this one through. So that's why that valve's there and that valve's there. So it isolates that particular bowl section of this venturi. So it's designed to have 700 CFM of air. I suggest you use it as such. So we've got our mince-up coupling, air in, the main plumbed sections. Then if you have a look here, there's another airline. So we've got an inch airline here with a mince-up coupling, 2 pins, whip check, double bolt clamp that's going in and running up the side of the unit. Well, what do I need that for? The pulse that I was talking about, the Goyen valves, they run off a little air receiver up on top. So those pulse valves need air to actuate and pulse through the centre of your filters. So this here has to be 100 psi. 100 psi in this inch hose feeds that receiver tank up the top. If there's not 100 psi in this, they won't work correctly. So on the other side of this machine, I'll show you directly where that's operated from. So the pulse does need a 12 volt system to run it. So that's why we've got a battery here, so that that is alligator clamped onto the terminals and the power is sent through to a control box on the other side. So fundamentally speaking, this is where the two adductor systems work, your valving, your inlet, your pulse air, and where this door arrangement here with these two knobs are, inside there are my 4 filter arrangements. So that gives me access to the filters. When do I need to access them? When I can't correct the magnehelic gauge increment of the vacuum within inside this, I need to have a look at those filters. They may need replacing, and they do have a service life. So if they need replacing, that's how I access those filters. It pays periodically, whilst on site, to check those filters to make sure that they're clean, they have been pulsed, or if the pleats in the filters are blocked completely, you know that they need replacing. The one thing you wouldn't suck through that vacuum hose is water while those filters are in place. The filters are a dry filter, designed for dust, designed to pulse dust. So if I sucked water into this machine, or this particular receiver, those filters would be undermined immediately and they would actually start to fall to pieces when it starts to pulse. So it's designed for dry, with the filters in there. Make sure that it's only dry when you utilise this machine and the filters are in place.